Here we are moving on to Unit 2. Hopefully the sound will be a little bit better. I heard your complaints, and I'm trying a different microphone this time. So Unit 3 is graphs and functions, and conveniently it will correspond to the graphs and functions PySlice and Alex. So let's go ahead and get started. In this first video, we're going to look at reviewing basic coordinate geometry, slope and midpoint, distance formula, linear equations and their forms, parallel, perpendicular, and then how to write equations of lines given different parameters. It's a lot, so buckle up and hang on. Starting with some basic review. So this is Cartesian coordinates. That's the x, y, z. Okay. Typically, we assume x and y is on the plane we're looking at, and z is out of the plane. But it all depends. So you're always going to want to look at your graphs to see what your axes are labeled. For the bulk of this class, we will just stay in 2D. And for this unit in particular, we're exclusively going to stay in 2D. So looking at x and y. Remembering that points are ordered pairs. So, and it's either going to be an ordered pair or an ordered triple for the third dimension. Some more review. A line is something that continues forever in both directions. Two things we need to graph a line is either a point and a slope or 2 points. So let's look at the 2 points for a second. So let's say I had 1, 3, and 3, 5. So that's my 2 points. And then I can take a straight line and connect them. Now, for a line, typically we keep it going and we put an arrow on either end. Okay, the arrow means it's a line. It continues in both directions. The other thing is we could look at a line segment and a slope. So let's say we had 2, 1, and we knew our slope was 2. That means a rise of 2 and a run of 1. So we're going to start here and we're going to go up 1, 2, over 1. It's our point, and then you connect the dots. A line segment has a beginning and end. So it's 2 points. So again, this is a line with arrows. This is a line segment. When we have lines, we have ways to describe the relationship between lines. The first thing we look at is slope. So that's this formula here. You're used to seeing it as rise over run. Okay. It also is the change in y over the change in x. And I represent change in, and mathematically and in science, we represent change as a delta. So this is delta, and it means change. Okay. Here in the US, we usually call this particular thing slope. But as you prepare for Cambridge exams, keep in mind that Cambridge uses the word gradient. So if you think gradient, think of grade. Not grade as in what you get in this class, but grade as in a dirt road needs to be graded smooth to have a slope of 0. And usually we denote slope with an M. Okay. If two lines are parallel, meaning they have the same slope, we can denote them with symbols like that. Hopefully you remember from geometry. That is when the slopes are the same. Now, this last bit, they are not collinear. What that means is if I have one line, as this bottom one, and I have a second line right on top of it, those are not parallel. They are the same line, so they can't be parallel. Moving on, our next one, we have parallel and we have perpendicular. Perpendicular means forms a right angle. The way you find perpendicular is the negative reciprocal. Okay, so negative 1 over m. So let's see, m2 equals 1 over negative m over m1. And this right here, m1 times m2 equals negative 1. That's your test for perpendicularity. That's the way you prove it. You can't just say, well, I took the negative reciprocal, it's perpendicular. You have to begin to show and prove your math, to prove your logic. So what you're going to do is if your m1 equals 2, you're going to say m2 equals negative 1/2, and then you're going to perform the test. You're going to do m1 times m2 equals negative 1, 2 times negative 1/2 equals negative 1, negative 1 equals negative 1. True. That's your proof for perpendicularity. That's how you know that two lines are perpendicular to one another. You can't go by look. You can't say, well, the picture looks like they're perpendicular. You have to prove it. Or it has to be given to you. So let's take a look at this one here. So we have A is 2/3, or 2 comma 3, and B is negative 2 comma 5. And they're on a line, and we want to know what the slope is. So I'm going to do change in y over change in x. So I'm going to do b minus a, 5 minus 3 over negative 2 minus 2. There we go. So as long as they line up vertically in terms of your ordered pairs, you're doing just fine. So if we look, 3 and 2 go together, 5 and negative 2 go together. So now we have to simplify. So that's 2 over negative 2, add the opposite over negative 4. So negative 1/2 is our slope. And then what is the slope of the perpendicular line to AB? So m1 is equal to negative 1/2. I'm going to take the negative reciprocal. So I'm going to say m2 is positive 2. And then remember, I have to take the check. So 1/2 times 2 equals negative 1. I get negative 1 equals negative 1. Thus, perpendicular. So this other one you're going to work in class. So now that we understand slope and points and how to graph them, we're going to look at how to graph linear equations. Okay. There are 3 different forms. Standard form of a linear equation we're kind of familiar with. If you look at it, it is similar to standard form of a quadratic in terms of ax squared plus bx plus c equals 0. You'll begin to notice as we continue our study that standard form tends to be an equation equal to 0. So that's standard form. Standard form doesn't really tell us a whole lot. Then we have point slope form and slope intercept form. They are derivatives of each other, and they are the 2 most useful forms of linear equations that you need to memorize. I'm going to start with point slope form because that is one of my favorites. Point slope form is exactly what it says. You need a point and a slope. If you have that, you can use this line. So if we think back to our example, which was negative 2 comma 5 was a point, and our slope was negative 1/2. So I could write that equation as y minus 5 equals my slope, negative 1/2 x minus negative 2. Simplify the negatives, but that right there is a perfectly acceptable form of a linear equation because it gives you the point and the slope. Now, if you distribute and you clean this up, so you'll end up with y minus 5 equals negative x over 2 minus 1. Well, let's see. Y equals negative 1/2 x plus 4. So all I did here was I moved my 5 over, rearranged, and now you see we have slope-intercept form, where m is equal to negative 1/2 and b is equal to 4. And 4 is our y-intercept. So generally speaking, point-slope form is going to be the easiest one to graph because you're almost always going to have a point and a slope in terms of, and easiest one to write an equation from. Slope-intercept form inherently has a point in it, right? It's the y-intercept, it's a specific point. But if you're graphing it, maybe the y-intercept is really far down and it's off of the scale of the graph that you're working with. So they both have their merits. They are both accurate linear equations. It's just a matter of what information you're given and which one's easier to use. So let's look at this one. We have slope is 1/2 and point is 2/3. So I can jump with the point slope form. I can jump straight to an equation. I can say y minus 3 is equal to 1/2 x minus 2. And that's a perfectly fine equation. With slope-intercept, if that's your preferred method, so this is point slope. If your preferred method is slope-intercept, what you have to do is it's y equals mx plus b. And we don't know what b is. So instead of plugging in, well, what you do is you plug in your point. So you say 3 is equal to 1/2 times 2 plus b. So you get 3 equals 1 plus b. B equals 2. And then you write your equation. Y equals 1/2 x plus 2. And that is slope-intercept form. So now we know the point, the slope, and the y-intercept of this graph, and we could easily graph. Once we establish points, slope, parallel, perpendicular, the next thing that comes into play is midpoints. So midpoint divides a line or a line segment, more specifically, into two congruent halves or two equal halves. And this is your midpoint formula. This is a formula that you're going to need to memorize. The midpoint formula is nothing more than the average between 2 points. So let's look and let's work one out. So you find the midpoint of m by joining the line segments. So I'm going to find my average. So I'm going to say 7 plus 3 over 2, comma, negative 1 plus negative 7 over 2. So this becomes 5. And then this one is negative 4. And if you want to check, you just say, okay, how far away is 3 from 5? Well, that's 2. If I go 2 up from 5, do I get to my other point? 7, I do. So that one checks out. And then how far is it from negative 1 to negative 4? Well, that's negative 3. And if I go negative 3, do I get to negative 7? I do. So this is m. That is our midpoint. Here's another one. Let's take a look at this one. So this is kind of putting everything together now. So we have a line and it meets a curve at A and B. So we need to find the coordinates of the midpoint of line AB. So the first, and then we need to find the length of the line segment. So if we look at this, first thing we need to know, the first question is midpoint. So that's this formula. In order to do that, we need x1 and y1. So we need to know what points A and B are. Well, A and B are where the curve and the line cross. So it's simply a matter of substitution. So we can say that x minus 3 squared is equal to 4x. All I did was take this and plug it in for y. So now we have x squared minus 6x plus 9 equals 4x. X squared minus 10x plus 9 equals 0. And then it's x minus 9, x minus 1 equals 0. So x is 9. 9 or 1. Now you could have solved this quadratic equation any number of ways. I recognize that factored. You could use the quadratic formula. You could have used your calculator. There's any number of ways you could have solved this quadratic. But that's only half of it. That gives us our x. So we know that A, let's call A is 1 and B is 9. But we know the midpoint then is 9 plus 1 over 2 is 5 comma something. We have to figure out what y is. So you pick one of your equations. I'm going to pick y equals x minus 3. And you plug in. So you get 9 minus 3. So it's 6. And then y equals 1 minus 3 is negative 2. Now we can complete the other half. Negative 2, or we can say 6 plus negative 2 is, so 6 plus negative 2 over 2 is 2. So our midpoint is 5 comma 2. And next is to find the length of the line segment. So this is our midpoint. The next thing it asks us to do is find the length of the line segment. So this is something we haven't talked about yet. So let's write this out. So the distance between points is the distance formula. And the distance formula comes from the Pythagorean theorem. So if we think about A and B, for example, there's going to be some change in y, some change in x, and what we care about is something I'm going to call C. Actually, no, I'll call it D as our distance. So our distance is going to be equal to the square root of delta x squared plus delta y squared. So again, that's the change in x squared plus the change in y squared. So if we look at our example here, so our x goes from 1 to 9. So it's going to be 9 minus 1 squared plus, we go back over, 6 minus negative 2. 6 minus negative 2 squared. So this is going to be 100 plus 64. So your distance is the square root of 164. Now, obviously, you need to factor 164 and simplify the square root. So let's look at what that would be. So 164 is 2 and 82, 2 and 41. And it's not 2, it's not 3, it's not 7. I think 41's prime. We could check it. So this is going to be equal to 2 square root of 41. That's how you calculate the distance formula. So this is the point P, which is equidistance from A and B. Find the value of K. So this one is tricky because you're going to be inclined to draw a line like this. That's not, and say they're equidistant, so P's the midpoint. That's not the case, though. You could graph it and find out. My recommendation to you is when you're drawing sketches to help you understand a problem, don't draw them in a way that makes the problem easier. Okay? Because if you draw this, you're inclined to say, okay, P's the midpoint, so I can just do the midpoint formula. But all we know is that P is equidistance from A and B. It has nothing to do with the relationship of A and B. So it could be an isosceles triangle. So don't draw the easy picture. You don't have to overly complicate your picture either, but don't draw it in a way that's going to lead you to make conclusions that aren't true. So now that we've got our drawing, so we know that the distance from A to B is going to be the square root of our change in x. So 8, we'll say the distance AP, sorry, is 8 minus k squared plus 11 minus 2k squared. And then we know that so this gets us k squared minus 16k plus 64 plus 4k squared minus 44k plus 121. So it's 5k squared minus 60k plus 185. Okay, and this is D, the distance from A to P. Now we look at a different one. We can say that the distance from B to P, zoom out so we can see, is going to be 1 minus k squared plus 12 minus 2k squared. Then we do this out again, so we get k squared minus 2k plus 1 plus 4k squared minus 48k plus 144. So we get 5k squared minus 50k plus 145. Now, we have the two distances. We know that they're the same, so we simply set them equal to each other. So we say that the square root of 5k squared minus 50k plus 145 is equal to the square root of 5k squared minus 60k plus 185. Both sides are square roots, so we can make those go away. Now it's just some simple algebra. So those cancel out. We add and subtract, so we get 10k equals 185 minus 115 equals 70, so you get k equal to 7. And there you go. That's how you work a problem like that. One step at a time, focusing on what you're given, what your question is, and how you can take one step. Now, this seems like a lot right now, but the only way to get better is through practice. So I've got several more problems lined up for you to practice in class. So what we looked at in this video was reviewing basic coordinate geometry, slope, midpoint, the distance formula between 2 points, and remember, that is the square root of delta x squared plus delta y squared. It's the Pythagorean theorem. Parallel, perpendicular, and how to write equations.